In this video, we're going to talk about how to sketch a graph of a rational function. And we have to go through all of these steps. Find the y-intercept, find the numerator and the denominator. And then we're going to find common factors, cancel them out, and those will be our removable discontinuity. And then in order to find x-intercepts, then each factor in the numerator will supply a y-intercept, x-intercept, sorry. So yeah, each zero of the numerator is the x-intercept. And then we're gonna find the multiplicities of each of those factors. Because remember when we were talking about polynomial functions, and we said that the certain value has a factor has a multiplicity of 2, then it bounces off the line. If it has an odd multiplicity, then it's gonna go through the x-axis. So the same applies here. Okay, then we're going to look at the factors in the denominator. So, and each factor in the denominator will supply a vertical asymptote if it's not going to be canceled with a factor in the numerator. And then if they can be canceled, then we're going to have a removable discontinuity. And finally, we're gonna look into end behavior and find the horizontal or slant asymptotes. And after that, we're gonna sketch the graph. So that's the plan. Those are the steps on how to graph a rational function. So here's an example 11. Let's do that. Let's go through all of these steps. And lucky for us, they already factored the numerator and the denominator for us. So if you can see it very well, I'm going to read it. In the numerator, we have two factors, x plus 2 and x minus 3. In the denominator, we have three factors. We have x plus 1, multiplicity 2, and x minus 2. Okay, so let's go down the list. Find the y-intercept. For the y-intercept, we're gonna set x equals 0. So when x equals 0, we're gonna have 0 plus 2, 0 minus 3, 0 plus 1 squared, and 0 minus 2. Okay, so that gives us 2, negative 3, 1 squared, negative 2. What does that equal to? Negative 6 over negative 2. So that's actually gonna be equal 3. So the y-intercept is 3, 0. No, 0, 3, sorry. 0, 3. That's our y-intercept for that graph. Then step 2, factor numerator and denominator, already done. Find the x-intercepts. So the x-intercepts come from the zeros of the numerator. So, and there we have x plus 2, and that gives us x equals -2. And the factor x minus 3 gives us x equals 3. So our x-intercepts are -2, 0, and 3, 0. Okay. Next, find the multiplicities of the x-intercepts. So here, each multiplicity is 1. Each multiplicity is 1. So meaning the graph will go straight through these points. Okay, for each factor in the denominator, note the multiplicities. Find the vertical asymptotes. Okay, so none of these factors cancel out, so there will be no removable discontinuity for this graph. But we're going to have 2 vertical asymptotes, right? So vertical asymptotes, again, the vertical asymptotes come from the factors in the denominator. We have x plus 1, which gives us a vertical asymptote x equals -1. And we have x minus 2, which gives us a vertical asymptote at x equals +2. And note that this vertical asymptote has a multiplicity of 2, and this is multiplicity 1. So what this means is that, remember how for our squared function, when we had 1 over x squared, then our function went in the same direction around along the vertical asymptote. So that's what's going to happen when your function has multiplicity 2. Basically, your function will go in the same direction on both sides of the asymptote. It doesn't have to be always up. It could go down. But it's going to go in the same direction both sides. As opposed to 1 over x, it goes into opposite directions on both sides of the asymptote. So that situation is going to happen around this vertical asymptote x equals 2. All right, what else do we have to find? Okay, there are no removable discontinuities. So no removable discontinuities. Okay, and the last step is horizontal or slant asymptotes. So the degree of the numerator is 2, the degree of the denominator is 3. There is a horizontal asymptote at y equals 0. Okay, so now that we gathered all of this information, we're gonna actually go ahead and graph this function. So here's my number line. Let's plot. The y-intercept is 0, 3, 1, 2, 3. Here we go. The x-intercepts are at -2 and 3. There we go. There we are. We have vertical asymptotes at x equals -1 and x equals 2. We also have normable discontinuity, horizontal asymptote at y equals 0. My cat is coming in. Okay. So remember that this asymptote has had a multiplicity of 2. So I'm assuming that my graph goes through this point, 0, 3, and it goes up and follows this asymptote. Okay, so, but it also has to follow this asymptote, and it doesn't cross the x-axis from in this interval. The only x-intercept is on the other side of the asymptote. So I assume it goes back up like this and follows this line further. Now, since this asymptote had multiplicity of 2, then on this side, the graph is going to follow this asymptote the same way that it does on the right side. And then we also have the horizontal asymptote. So this branch is going to do this. It's going to follow the horizontal and the vertical here. Oh no, I'm sorry. It has to. We have an x-intercept here. So it actually has to cross the x-axis and then go follow the horizontal asymptote. Okay. So it's actually gonna go like this. Okay, on this side, since this is multiplicity 1, this factor was a multiplicity 1, then the function is gonna go in the opposite direction from the left side. It's gonna go down and it's gonna cross x-axis at 3, and it's also gonna follow the horizontal asymptote going to the right. So this is what the graph looks like. And this is what Desmos graphing utility shows me for this graph. Well, we were pretty close, weren't we? So this is how you analyze your graph, your equation, and graph it. So you need to follow all of these steps in order to create this graph. And now I would like you to try this problem by yourself. You have a function. In the numerator, you have x plus 2 squared multiplied by x minus 2. And in the denominator, you have 2 multiplied by x minus 1 squared and x minus 3. Okay, try it again. Let me know if you got it. Don't go straight to the graphing utility. You can use graphing utility to check your work, but first try to graph it by analyzing the equation. And I'll see you in the next one.